What is conditional probability? If we have 10 cards numbered from 1 to 10, out of which we select one card at random, the sample space of this random experiment would consist of the set U containing the numbers from 1 to 10. Now, if we define the event A consisting of obtaining an even number, in the sample space, the even outcomes are 2, 4, 6, 8, and 10. Then event A would contain these even outcomes with a probability of occurrence of 5 out of 10, as 5 out of the 10 outcomes in U are even. Now, if we define the event B consisting of obtaining a number greater than 3, in the sample space, the outcomes greater than 3 are from 4 to 10. Then B would contain these outcomes with a probability of 7 out of 10, as out of the 10 elements of U, 7 are greater than 3. Now, if I define the event consisting of obtaining an even number, knowing that it is greater than 3, obtaining an even number is in fact event A, while obtaining a number greater than 3 is in fact event B. Then this event is looking for realizing A on a condition that B is definitely realized. This is a conditional event denoted by A given B. And since B is definitely realized, we are now looking at B as a reduced sample space. And we look for the numbers that are even only in B. Then the probability of A given B is 4 out of 7, as 4 of the 7 outcomes in B are even. This is a conditional probability, as it is found based on a reduced sample space defined by a given condition that B is definitely realized. Now, looking carefully, we notice that the even outcomes in B are in fact from the intersection of A and B. Then the probability of A given B can be seen as the cardinal of A inter B divided by the cardinal of B. Dividing both the numerator and denominator by the cardinal of the sample space U, we obtain the probability of A given B to be the probability of A inter B divided by the probability of the condition B. Then you can in fact find a conditional probability either using the reduced sample space or using the final derived formula.